Hello, all my YouTube subscribers. I'm putting together a very special video today to celebrate getting to 1,000 subscribers. Now, at the time of this recording, I have not reached yet. I'm at 997, but we are getting pretty close. So I want to get this video ready so that hopefully it can go up around that time. What I made is this cool little flame game. And it is a game, and I'll show you why in a minute. And basically, the idea is that there is a unique little person for every one of my subscribers. So there should be 997 of these guys. Now you see something interesting. There's some with sunglasses. And the way this actually works is when this game launches, only one of them has sunglasses. But as soon as a sunglass dude combines with a non-sunglass dude, the non-sunglass dude also gets sunglasses. So it's kind of like almost like a manhunt kind of game. And if I actually rebuild this here, reload it, we only have, 8 now, so it's growing. And the idea of this, if we want to call it a game, is you're trying to find someone with sunglasses as soon as possible. So as I sort of search around here and look, there's already been 44, so I'm not doing great. This isn't a very good speed run. But okay, there's some there. And I basically want to click on one. And although I haven't made any UI for this at this time, I got this many points. And it's basically 826,000 points. That's amazing. I definitely want to, quickly add something in here when we hit the 1,000 that actually kind of puts it in your face. But I'm running out of time, so I just wanted to get this recorded. And the way the points work is it's basically, the sooner you get it, the more points you're getting. And it's a pretty simple algorithm for that. If you click someone once all 1,000, or in this case 998 people have sunglasses on, you get 0 points. So it's kind of it's not really a game, but I just want to celebrate, and everyone here has a unique combination of hair and clothes and body and that kind of thing. So cool showing this. Also, wanted to show you how I made this. So I built this in just a few hours. It wasn't too difficult because I've been working on a project in Flame, so I'm a little more familiar with it. And I'll kind of walk you through how it works here. So we'll just start right at the main.dart. And essentially, we'll skip over all this stuff here for now. But the main important thing is we have this, I'm using RiverPod for the state stuff, so that we can kind of, capture how many people have this, as well as get the actual live subscriber count. But basically, we have our game in here. And the game itself is just a flame game. And when we load it, we want to load all of our images. So we'll actually see in assets images, we have, stuff for the characters, the different clothes, all that kind of stuff. And I actually got these assets from a really cool package called Cozy People Asset Pack. And they come in there's a whole bunch of different animation. So walk, I'm only using walk. I'm using the 4 different ones, left, right, up, and down. But they have a whole bunch of other things. And then they have different hairstyles, different clothes, different kinds of things. And they all come in separate sprite sheets that you can actually layer on top of each other, and it works pretty well. But basically, we load all those images in, we construct our level, and I'll look at this in a minute. We create a camera, and we actually have a camera controller, which is really just a positioned component that has some keyboard events on it, so that we can essentially use the arrow keys to move around. And then we attach, we follow that camera controller so that the camera is actually following wherever that is. And then we add it all to our game, and everything goes. So the level itself, what I'm actually doing, so I load the map first. We're using something called Tiled, and Tiled's a really cool program, which I'll just load up real quick. So this is a free app you can get for, I believe, all operating systems. And I basically just created a map in it, and it kind of has, 1K or whatever, and some like random grass. Didn't spend a ton of time on it, but it allows you to sort of create in there and actually load that, as well as all the tiles and images that go with it. Then for my load characters, I'm getting the total subs from this provider that I'll show you in a moment. And we're actually just looping through all of them and setting some random starting positions. And we're also creating some random skins. And a skin is basically the outfit type, the hair type, there's different eye colors, different hair colors, that kind of thing. And the randomization function basically just gets random integers or random in a list, depending on what it is, and returns it. And then it just adds that character to the screen. Now, one thing that's interesting here, has sunglasses, is something I can pass through, and I only pass it through when I is 0. So in this loop, it would only be the first person gets sunglasses. And that was just a little fun little Easter egg sort of thing. I was like, let's make this a little more fun. Added that at the last minute, and it's pretty cool. A character is really just a sprite animation group component. And I've created 4 different sprite animations. So the down, up, left, and right. As well as an outfit that they're going to have. And an outfit is really just another component that looks very similar to character. The only difference is there's no interactivity. So all of these different things, whether it's outfit, eyes, or hair, they basically load from a specific sprite sheet. And when it gets into this, it actually goes and takes the outfit and adds it, takes the eyes and adds it. And just the way that that sprite sheet is built, they're all already positioned, in the correct spot in the 32 by 32 pixel skin. So I'm creating all those animations, and I'm actually also starting it with a random walk direction to start, so they're not all just like staring at you in the face, which might seem weird at first. And then we're actually adding a hitbox to all of them. Now, I'm not making the hitbox the entire character. And the reason for that is, I want, because this is kind of like a top-down thing, someone should collide when they're kind of close, but like they should be able to also walk behind each other. So the hitbox is actually just 9 by 9, and it's offset so that it's kind of in the center. And that's something, built into Flame. You can make hitboxes. So that's our like load function, basically. The update function, what I'm doing every update is I'm actually taking their y coordinate and making that their priority. And priority is like the Z index in Flamed. So basically, if someone is at a larger y, they'll come in front of someone that's behind them. So it's just, you don't get the weird layering, because otherwise they would just be layered in the order they were added, which doesn't make sense. And I'm doing this little trick here. Rather than using the delta time, this is just a way to make a fixed delta time, so that no matter what, if the program's running at maybe you have a really good machine and you actually could be getting 200 frames a second instead of 60, which is the intention here. This essentially is a way to fix that, where you are looping through, you're adding accumulated time, and if it is greater than the fixed delta time, you actually run this function. So it only will run, because our fixed delta time is 1 out of 60, it'll only run, it'll run 60 times per second, basically. The walk function, basically what it does, first of all, it finds out just what the last walk direction is, and that's just something I'm storing on the state of each of these characters. And I'm doing a bit of testing to make sure they don't hit the edge of the screen. So these are just some sort of magic numbers that, because it's a 100 by 100 grid. So if they happen to be, at the bottom of the screen, y being greater, we turn them to go up. And then, if they're on the right side of the screen, we turn them to go left, that kind of thing. I also want them to randomly change direction sometimes, but I don't want, if I kind of force it, hey, you need to turn around now, I want to set this to false so that this never runs. So basically, this just does a random int of 300. 0 to 300, and if it happens to be 0, it'll randomly change directions. It just gives them a little bit more like intelligence of randomization. And then all we do is we switch on the different walk direction that we've come up with here, and we set their vertical movement or their horizontal movement accordingly. And then this is just the function that actually moves them. So we set their velocity based on these things, and then we update their position based on whatever the velocities are. And that's basically where it goes. And then anytime they do change, because I don't want to call this every single frame. So if there is a difference between last and walk, I actually run this update state. And this is the thing that actually updates the state of the outfit, because there's actually, the outfit looks different from, depending on the walking state. The eyes will be different. The hair will be different. So we actually update this by setting those components sort of things. And I also, when they're walking up, I want to turn their sunglasses off, because otherwise the sunglasses kind of just like float on the back of their head, which doesn't make sense. So we actually do that. Otherwise, we set it to true if they have sunglasses. We set it to 1. So that's kind of the logic there. And then for collision detection, because we have this collision box and we are inheriting collision callbacks here, or the mix-in collision callbacks, we can actually check if anytime in a frame there is a collision. And if the other collision is a character, we do this change direction function. and we check if other has sunglasses and I don't have sunglasses. We then talk to Riverpod to say, like, let's increment that number. And that's basically just what's being used to show this number right here, because this is actually outside of, this isn't being rendered by the game engine or by Flame. This is being rendered by Flutter outside. The game's just kind of like a layer underneath. So we do that, and then we set their opacity, assuming they are not walking up. We want to set it there just so it happens instantly. So that's kind of it. I did do something where, because collisions, sometimes they're happening every frame, I actually set it to, if it already has collided, we return out of this. We don't, keep calling this function basically. And then that way it's just, more efficient. And then we set it back to false 300 milliseconds later. So that's kind of the logic of everything there. It's a pretty basic game, if you want to call it that. Now, what I spent a bunch of time figuring out is how can I get my live, more or less a live version of, how can I get a subscriber count, right? So what I decided to do is just build something pretty simple in Dart. I'm using Dart Frog, which is a cool package for just simple server applications. And basically, I'm just using the YouTube API. I'm using it raw. I did try using the there's a YouTube package, but I was having a bit of trouble with it. So I'm just using DO, and I'm actually just calling this endpoint. I do have to do a little bit of work in the background to actually get my authentication token. This, thing isn't perfect, but basically it just gets the data from here. And then I look inside data, item, statistics, subscriber count, and return an int. And this just returns, if I actually go to here, I'm just running this on my 8080 and 998. That's the number that it's getting. Then back on the Flutter side, I essentially have a subscriber count provider. So this is just a very basic Riverpod provider using the generator, and I call that same endpoint, and return this. And if for some reason something goes wrong, just so that I'm not, having problems, I'm just returning 1,000. So I'm being optimistic that I will hit this 1,000 right here. And if there's an error, it also returns 1,000. Then, I just don't have to deal with nullable issues and stuff like that. So not perfect, just, enough to get the job done and kind of have a full stack Dart application here with Flutter, Flame, and Dart Frog. So there we have our fun little game here. And I might put this up somewhere on probably just as a web app. And then, I'm going to add a little bit of UI to actually make this score show up on the screen, because you obviously wouldn't be able to see it, but people can obviously play with it. And then, of course, I'll be putting the code up on GitHub too after launch. So thanks for everyone for subscribing, and I hope you can find yourself somewhere in this sea of little people.